Hey everyone, welcome back to the channel. In today's video, we will learn how to build Docker images using Dockerfile from the scratch. We will cover what a Dockerfile is, common keywords used in Dockerfiles, layers in Docker images, multi-stage builds, and finally build two Docker images, one for Python app, another one for Java app. I already have some sample Python code and app code that I will be using during the building of these images. A Docker file is simply a text file with the instructions that tell Docker how to build an image. It automates everything from installing dependencies, copying code, and to setting up the environment. Some important keywords on the Docker file are from. It sets the base image. Run. Executes the command during the build. Copy or add. Copies the files into the container. Work dir. It sets the working directory. CMD. Default command executed when a container starts. Entry point. It sets the entry point for the container. Expose. It specifies the app port. Volume. Mount storage for the persistence. Each instruction in a Docker file creates a new layer. For example, from creates the base OS layer. Run apt install creates a dependency layer. Copy app.py creates the application code layer. The best part, Docker caches these layers and make the builds faster. Multi-stage builds help optimize image size. Instead of shipping extra build tools, we split Dockerfile into a build stage and a runtime stage. For example, the first stage builds the app with Maven or Cradle. Second stage copies only the final compiled artifact into the small image. Alright, let's move to the demo part. Engine where I will build these Docker images. If I run ls-l, I have two folders. One is for Python app, another one is for Java app. Let's go to the Python app folder first. Inside this Python app folder, I have a Python script and requirement.txt. I will be using these files while building the Docker image for this Python app. In order to build the Docker image, first we need to create a file. That file name is Dockerfile and D is caps here. So let's create a file using VI editor. Enter into the insert mode and type the first keyword here from. Next, specify the base image. In our case, it would be Python. Hit enter, type work dir. It will set the working directory. In our case, it would be /app. Hit enter. Next, copy the requirement.txt file under this app folder. For that, use copy. Specify the file that you want to copy. In our case, is requirements.txt. Next, install the dependencies using this requirement.txt file via pip install command. For that, first define the word run and then specify the command pip install -r and then requirement.txt. Hit enter. Now copy the app code using copy command. And in the last, we'll define a CMD which will start our application. So this will be executed whenever a container is started using this Docker image. Under CMD, we need to define the exact command that we want to execute when we start this container using this Docker image. Type here Python and then your app name. Save and close the file. In order to build this Docker image, you need to run the command docker space build space -t is for tag. Tag means just labeling the Docker image. In our case, I will set it as Python -app and dot. Dot means it will look for this Docker file inside the current working directory. If you hit enter, it will start building the Docker images. So this is completed. Now you can verify the Docker image. Run the command docker images. You will see that a python-app Docker image of size 132 MB is created. Let's create a multi-stage Docker file for our Python app. Multi-stage builds help create much smaller images by separating the build environment from the final runtime image. Let's edit the Docker file. Remove these lines. For the interest of time, I have already prepared the set of instructions for this multi-stage Docker file. Alright, if you can see, I'm defining the first stage as build stage. In the build stage, I am pulling this image as a builder. I'm setting the work directory as /app, installing the dependencies using the requirement.txt file, and running the pip install. After that, I am copying the app code to this app folder, and then I'm starting my second stage, that is runtime stage. For that also I am using the same Python image, setting the work directory as again as /app, and now I am copying only the installed packages from the builder and updating the environment or updating the path environment. Once it is done, then I am copying the app code and then exposing the app on the port 5000, defining the volume for our app under /app/data, and then running or starting the app using the Python command. So this CMD, whenever this container got started using this image, it will run this command python app.py, which ultimately starts our application. Now save and close the file and build the image. For that, rerun the command docker build space -t and the tag name. This time I will specify space dot, hit enter. Dockerfile creation is also completed using this multi-stage. Now verify the Docker image size. Alright, in order to test this Docker image, we will start a container. Let me clear the screen first. Run. Now verify the container. Run docker ps. It has started a container using the image that we have just built using multi-stage. Alright, it has started this command python space app.py. It means our application also got started. Now validate this. Open the browser, or you can also test it from the command line. You can simply run the curl command here. Hit enter. You will see the output something like this: hello from Python Dockerized app. It means our application is started successfully in the container using this Docker image. Alright, let's move to our second demo where we will be building a Docker image for Java app. Let's go to our Java app folder. You do ls here, you will see our pom.xml and our Java app code under the src folder. Let's create a Docker file here. If you see, I'm defining two stages, so it means I'm using multi-stage Docker file here. In stage 1, I'm saying it's a build stage. So for this build stage, I'm using this Maven based image as a builder. I'm setting this work directory as /op. I'm copying the pom.xml file under this app folder and then copying the entire Java code from this src to this src folder, and then building the package using mvn clean package. The next stage, where we are using a slim base image and we call it as slim runtime. Here I'm specifying that this is the image I would be using it as a base image. Work directory is again /app. I'm copying the artifacts or the jar file that was build in this build phase directly from the builders to this image, and then exposing this application on the port 8080. And in order to start this application, I'm using entry point here, and I'm executing the command java space -jar and then app.jar. Once this is executed, it will start our application. All right, save and close this file. Now run the docker build command in order to build this Docker image. The tag name is Java app and then dot. Hit enter. Sorry, typo. Let's correct it. It's build. Okay, the output confirms that Docker image has been built successfully. Let's verify it. Run the command Docker images. Our Java based Docker image is created. Alright, let's start a container using this Docker image, and let's validate whether our application is accessible or not. Let me clear the screen first. And the command docker run -d -p 8080. Image name is Java-app. Hit enter. Run docker ps. You will see one container got started with the name this one. It is using this image that we have just built, and it is executing the command java space -jar space app.jar. So it will start our application. It's the same command that we have defined in the entry point keyword in the Dockerfile. Let's try to access this application. Run the command curl. Alright, we are getting the response from application. This confirms that our application is accessible using this container, which is started using this Docker image. That's all from this video tutorial. I hope you have found it useful and informative. Do not forget to like, share and subscribe for more DevOps tutorials. Thank you. Bye. Have a nice day. See you in the next one.